Today we're going to learn about dividing radicals, and this is a one of two lessons in your workbook. We're starting with page 117. And as we start this lesson, I want you to remember one of the previous ideas we explored, that if we are taking a root of a fraction, such as a over b, it would be the same as if you were to write that as just the root of the numerator divided by the denominator. And what I mean by that is, if let's say you have root of 15 over 5, it is the same as root 15 over root 5. So you can actually switch between these two formats when it is easier for you to work with either one of them. They will give you, it's the same answer. So that really helps us when we're doing division. So the division here is written in a fraction form, m root a divided by, so divided by n root b. So if I were to write that as an example, so remember, it is okay for me to think of this radical, the fraction form, as just 15 divided by 5. And we're going to see what the rules for dividing radicals are. Okay. So when dividing radicals, first thing you just have to make sure before you start actually going through the steps is that the index has to be the same. Okay, so an example that we have here that I can show you guys, if I use the one from previous page again. So this is not in your book, I'm just making it up. So what are the rules for it? Let's go through it. It says divide the numerical coefficient by the numerical coefficient. So in here the numerical coefficient is 6 and 3. So that means the 6 and 3 can divide or reduce each other. Sometimes they don't divide up completely. Sometimes they just reduce, and we can do that. In this case, they will divide up completely, and we get the answer of 2. So that's what step 1 is. Step 2 means the radicand can only divide the radicand. So that means this 15 and the 5 can divide each other. So remember, we can think of it as just 15 divided by 5. You don't have to rewrite it that way, which means I can divide it out completely or reduce it. In this case, it will divide out, and this will be 3. So that stays as root 3. Now 1 root 1 is just over 1, which can be just written as 2 root 3. So that's what they mean, divide the numerical coefficient by numerical coefficient, radicand by radicand. And if in the end this number, this radicand, is still a more complex number that can be simplified further, we should. And that's going to be a rule all through our radicals. Just like in fractions, we always in the end try to reduce them when possible. In radicals, we always try to simplify into the simplest form when possible. So the only rule is that our index has to be the same. So if this question was given to us with a different index, then these radicands, this would be like, let's say, square root. Now this we could not do because this is a cube root and this is a square root. So if you have different indexes, we cannot reduce those. Okay, that means we cannot divide them.